ARCI's receiver tube technology for solar thermal systems. India, a rapidly growing economy with more than 1 billion people, is facing a huge energy demand. To meet this surging demand, solar energy is the best form of energy to fulfill the needs of India and bridge the demand-supply gap. The potential of solar energy is realized in 1931 by famous scientist Thomas Alva Edison and stated that, "I'd put my money on the sun and solar energy." What a source of power! Solar power is inexhaustible and environment-friendly. India is endowed with vast potential for solar energy due to the average solar incident radiation of 4 to 7 kilowatt-hours per square meter over 300 days. Solar energy can be harvested majorly by photovoltaics and solar thermal systems. In photovoltaics, solar energy is converted into electricity using semiconducting materials, whereas solar thermal systems convert solar radiation into heat. The heat can be used for different applications such as solar cooking, water heating, space heating cooling, industrial process heat and power generation applications. Concentrated solar thermal systems has a huge potential in comparison with the photovoltaics because of advantages such as low-cost thermal storage and high conversion efficiency. Concentrating solar power plants use mirrors to concentrate the sun's energy towards the receiver to convert into heat and to drive traditional steam turbines or engines that create electricity. Solar receiver tube is an essential component in solar thermal systems and plays a key role in converting solar radiation into heat energy. The receiver tube with high solar absorptance is greater than or equal to 0.95 in the region of 300 to 2500 nanometers. Low thermal emissivity is less than or equal to 0.15 in the range of 2.5 to 25 micrometers is a vital component for solar thermal systems. The receiver tube converts the incident photons into phonons with low emission that results in the generation of heat energy. However, the factors such as cost of receiver tubes, lack of indigenous technology and non-durability of coating at an operating temperature are some of the reasons for solar thermal systems being still behind the photovoltaics. In this connection, ARCI has developed an indigenous receiver tube technology to reduce the cost and to improve the photothermal conversion efficiency of solar thermal systems. Low-cost coating techniques such as chemical oxidation, sol-gel and nanoparticle suspension methods are employed to develop receiver tubes technology. After continuous efforts, ARCI has successfully developed a simple, cost-efficient receiver tube technology for medium and high-temperature applications. The receiver tubes exhibited high solar absorptance is greater than or equal to 0.95, low thermal emissivity is less than or equal to 0.15 with good thermal and corrosion stability. The medium-temperature receiver tube is thermally stable up to 300 degrees Celsius and highly corrosion resistant and potentially can be used for various applications such as solar cooking, water heating, solar cooling, and industrial process heat applications. The high-temperature receiver tube is thermally stable up to 500 degrees Celsius due to novel spinel phase and can be used for power generation applications. At present, there is no commercial receiver tube is available which can be thermally stable at 500 degrees Celsius for 250 hours in open-air atmospheric condition. ARCI has successfully developed 2-meter prototype receiver tubes with the targeted optical properties, and the medium-temperature receiver tubes are validated with the assistance of the established parabolic trough test rig facility. The established parabolic test rig is first of its kind in India, and the components such as reflectors, receivers and heat transfer fluids can be validated by the test rig. The validation results conclude that the ARCI's developed receiver tube technology is superior with the commercially available non-evacuated receivers in terms of heat gain, loss and weather stability. ARCI also provided receiver tubes to various companies, and validation of the receivers for various applications like solar water heater, parabolic trough and linear Fresnel reflector are in progress. Multiple patents have been filed for receiver tube technology and transferred to an Indian company.